Topic today is electromagnetic induction, and I'm first going to give you an example on paper of what that looks like, and then I'm going to give you some demonstrations, physical demonstrations as well. So to start with, this is a page from a previous lecture that I gave. That lecture was called Another Electric Motor. If you haven't watched that one, this would be a good time to pause the video and go back and check it out. But in a nutshell, I made the argument that this setup behaves like an electric motor. And why is that? Well, I have electrical energy coming from the battery, and it creates a current in this coil. And we know that this current will create a magnetic field. And I showed you the third right-hand rule. So if I curl my fingers in the direction that the current is traveling around this cylinder, my thumb points in the direction of the north pole of the magnetic field that is created by that current. So this solenoid is, we call it an electromagnet. It's behaving like a bar magnet. It has a north end and a south end. Over here I have a bar magnet, and I put the bar magnet on a rail, and so that it can only go left and right. And here, since this is a south pole of this electromagnet, and this is the north pole of the bar magnet, then they attract. And that's going to cause the bar magnet to slide to the left. This is assuming we're holding this electromagnet fixed in place. Okay, so this is a very simple example of an electric motor that takes electrical energy as the input and produces mechanical energy, that is the energy of motion, as its output. Okay, now let's talk about electromagnetic induction. So I've redrawn the setup for the electric motor, but I've removed the battery. Okay, so there's no current in this coil because there's no battery to provide the current. And we saw with the electric motor that if I provided electrical energy here to create a current, I could create mechanical energy by moving this magnet. And so the question that I'm going to ask now is, can we reverse this process? Can we, instead of providing electrical energy to get mechanical energy, can we provide mechanical energy? Well, yes, we certainly can, right? We can take this magnet and use some other force to move it. We could use our hand, or we could use some other external force to push this magnet. And so the question is, if I provide the mechanical energy, will I get any electrical energy coming out right here? And the answer is very surprising, and one of those magical results, which is that yes, I will get electric energy here. So just by reversing this process of the electric motor, instead of providing electrical energy and getting mechanical energy, if I provide the mechanical energy, I will get the electrical energy. So this is a reversible process. Okay, so if I were to move this magnet, okay, it doesn't matter which way, you'll get, well, we'll get into more details about what the difference is between moving towards and farther away. But for now, whether I move it closer or farther doesn't matter. If I put a voltmeter right here, instead of a battery, I just put a measuring device. This voltmeter will register a voltage when I move this magnet. All right, so this is called electromagnetic induction.